Hey everyone, thanks for tuning in. My name's Martyn, and this is my Agile Back to School session on building a scalable multi-tenant cloud-native application. So, what are our objectives for this session? There's a lot to get through and a lot of useful information, so I wanted to just go through some of the things that we're going to go through in this presentation. So, the first thing is, what is cloud native? I just want to make sure everyone has a solid understanding of what cloud native is before we actually get moving into some of the details. I also want to talk about how multi-tenant applications differ from standard applications. It's an important understanding that I need to sort of convey across before we go through again into more detail. And I want to talk about architecture patterns, and there are lots of different architecture patterns. So I want to go through a few of the most popular ones and talk about some of the pros and cons of working with those different patterns. So you have um, really more information to make an informed choice as to which one you would use within your specific use case. And then I want to finally talk about why it's really imperative that you practice DevOps when working with cloud native multi-tenant applications. And you'll understand why I want to talk about that a little bit towards the end. So, first of all, what is cloud native? So, let's look at the Cloud Native Computing Foundation's official um, description or official quote, if you like. So, cloud native technologies empower organizations to build and run scalable applications in modern, dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. So that's a really good explanation, and one that going through there, you hopefully recognize some technologies that you maybe use today that support that description, be it in Azure or AWS or any cloud environment for that matter. Um, but I want to go a little bit further and sort of expand on this explanation. And the first thing really is that cloud native is really around speed and agility. So business systems are evolving from enabling business capabilities to real weapons of strategic transformation, and they accelerate business velocity as well as business growth. So it's imperative to get new ideas to market immediately and as quickly as possible to stay ahead of your competitors. At the same time, business systems are also becoming increasingly complex with users demanding more and more from applications. They expect rapid responsiveness, innovative features, and things like zero downtime. So, traditional issues like performance problems, errors in systems, and the inability to move faster are no longer acceptable for users today with applications that they use. So, your users will visit your competitor. Cloud native systems are designed to embrace rapid change, large scale, and resiliency and help support some of these things that help your business grow. Excuse me. So, how does multi tenant differ? So, first of all, let's have a look at what multi tenancy is. So, multi tenancy is a process where your application is used by multiple customers that we may also call tenants, and they're distinct from users. So they're a different thing to users because you may have an application that supports multi-tenants that requires user-based logon within those tenants as well. So multiple users can be from a single organization or a group and form a single tenant. And when building multi-tenanted solutions, there are lots of elements that you need to consider further. So some of these considerations, and there are quite a lot. So some of these considerations are, how do you define what a tenant is for your solution? So it's really important to make sure that you have a real clear view as to what constitutes a tenant. Is it an organization? Is it a group of specific users matching certain criteria or properties? Could be anything, but it's really important to define what that is first. Next is how do you deploy infrastructure to support that multi-tenancy? And I'm not going to cover that too much here because we're going to talk about architecture patterns in a little while. Next is around pricing models. What pricing models are you going to offer and how does that affect requirements? So depending on whether you pick maybe a pay-as-you-go model, whether you pick a pay monthly model, or whether you offer a freemium service, or whether you offer a trial-based solution first, that is going to affect the requirements of your application. And those things are effectively going to potentially change the considerations you need to make and change your architecture of your application. So it's important to think about those things at an architecture stage first. Next is around what level of service do you need to provide? Is this service going to be something that is business critical for your users? If it's going to be business critical, you need to think about what level of service you're going to provide. Do you provide 24/7 support? Do you provide out of hours support? It may be a follow the sun support model. Do you provide support at all or just in-depth documentation? There's lots of things that you need to consider. Next is how do you plan to grow your business or solution? And this is very much a loaded question towards business rather than technology, but it has some technology undertones as well. And that is that if you plan to grow your business or solution, the technology has to support that plan. So there has to be something in place which provides the ability from a technology perspective to support that rapid growth and to support the ability to be able to deploy what you need to deploy whenever you need it based on whatever demand there is for your application. Next, around unusual requirements. And if you do have unusual requirements, how do you deal with those unusual requirements? So let's think of something that might fall into this category. So compliance is definitely something that falls into this area. So compliance is something that affects different organizations in different ways depending on the vertical that they sit in. Some organizations require deeper levels of compliance depending on whether they may be in financial services or healthcare, for instance, than other solutions or other providers of different services. So if you have those unusual requirements, document them and detail how you're going to deal with them when they come up in your solution. Otherwise, again, people are going to go to your competitors because you can't fulfill their requirements. And then probably one of the most important things is obviously security, right? Do not leave security to last. Think about how you are going to secure, manage, monitor, and importantly, automate, scale, and govern your environment. It's really important at a design stage to understand what the security implications are of your environment, where the weak points might be, how you're going to protect it against different levels of attacks, what your attack vectors are, and understand how you're going to configure your services to mitigate these problems. Management and monitoring, also very important things. How do we know when there's a problem and how do we make sure that the right people are notified that there's a problem? Monitoring is critical to understanding how your organization is behaving in terms of the software that you're providing to your customers, and understanding that helps provide good customer service as well. Next is around automation and scaling. So we've talked about it through several different views before, but from a pure technology perspective, you do not want to be hiring people every time you scale your business. You want to be having an automated model that means that for every 6 or 7 customers, you maybe need to hire additional people, rather than every customer you hire means that you need to hire additional people within your business. That's not a sustainable model. And then finally, governing your environment. And this comes back to unusual requirements. If there are requirements for things like compliance, how are you going to govern your environment to meet those requirements and be able to provide statements of attestation back to your customers to be able to say, yes, our solution provides conformity to these specific standards. And then last but not least, something which I see people get caught out on all the time is thinking about your quota limits and your resource limits within Azure. So don't forget that you can't just deploy as much as you want wherever you want. There are limits, and yes, some of those limits can be increased, but some of them can't. So think about what resources you need to deploy and how scalability affects those resource limits, and whether that means that you split up your production and development environments into maybe separate subscriptions to negate some of those limits, or whether you split them up into a regional model to help with some of those. There are lots of different options, but do think about it before you start building your environment, because the worst thing that can happen here is you get to the point where you've built this really great solution and you get to the point where you've onboarded, say, 20 customers and you can't scale anymore because of decisions that you've made along the line. Okay, so next we're going to talk about architecture patterns, and the first pattern I want to talk about is the logical and physical tenants. So the first thing here really is that you need to determine what a tenant means for your particular solution. We discussed that on the previous section as a consideration. And determining what a tenant means for your particular solution and whether you should distinguish between logical and physical tenants. So for instance, for example, consider any kind of music streaming service. So initially, you might build a solution that can cope with maybe thousands or even tens of thousands of users. And as you continue to grow, you might find that you need to duplicate your solution, or at least some of its components, in order to scale to your new customer demand. That means that you'll need to work out how to assign specific customers to specific instances of your solution. That might be something you do randomly or geographically, or by filling up a single instance and then spilling over into another one. However, you probably need to maintain a record of which customers you have and which infrastructure their data and applications available on, so that you can route their traffic to the correct infrastructure. In this example, you might need to represent each user as a separate logical tenant and then map to physical tenants that represent the different instances you've deployed. So you have a one-to-many mapping between logical and physical tenants, and you can move logical tenants between physical tenants at your own discretion. So in contrast to that, think about a company that builds cloud software for, say, legal firms. Your customers may insist on their own dedicated infrastructure to maintain compliance. Therefore, you need to be prepared to deploy and manage different instances of your solution right from the start. In this example, a logical and physical tenant is the same thing. Key difference between logical and physical tenants is how isolation is enforced. When multiple logical tenants share a set of infrastructure, you typically rely on your application's code and a tenant identifier in a database to keep each tenant's data separate. When you have physical tenants, they have their own infrastructure, and so it may be less important for your code to be aware that it's operating in a multi-tenant environment. When you're looking at testing these in the future, you need to think about things like noisy data effect, or noisy neighbor effect, as we call it. And this is a test to make sure that data from one tenant does not leak into another tenant. And noisy neighbor effect is where, if we have a tenant that is running lots of a specific task, that the performance there doesn't affect other tenants within the same stamp, the same physical arena. And you can test the isolation model using Azure Chaos Studio. Next is tenant isolation. So rather than thinking of isolation as being a discrete property, you can think about isolation almost as a continuum. So you can deploy components of your architecture that are more or less isolated than other components in the same architecture, depending on your requirements. So from a security perspective, if you share infrastructure between multiple tenants, you need to be especially careful not to access data from one tenant when returning responses to another. And this is what we just talked about around data leak. You need a strong foundation for your identity strategy, and you need to consider both tenant and user identity within the authorization process. Next, from a cost perspective, shared infrastructure can be used by multiple tenants, so therefore it is cheaper. It's a very simple um, definition there, but it's something that a lot of people sometimes lose sight of. From a performance perspective, if you're sharing infrastructure, your system's performance may suffer as more customers use it, since the resources may be consumed faster. So think about a tenant isolation from a performance perspective as well. And from a reliability perspective, if you're using a single set of shared infrastructure, a problem with one tenant's components can result in an outage for everyone. So think about how the components interact with each other, and think about how you're going to handle downtime, and how downtime will affect either individual tenants, multiple tenants, or all tenants. Next is around responsiveness, and this is a responsiveness to individual tenants' needs. When you deploy infrastructure that's dedicated to one tenant, you may then be able to tune the configuration for the resources within that specific tenant's requirements. You may even consider in that particular model enabling customers to pay more for isolated deployments. And with that, obviously, comes an increased cost to you that you would need to then pass on through the cost of your application. Your solution architecture fundamentally influences the options that you've got available for your isolation. So, for example, let's think about an example 3-tier solution. Your user interface tier may be a shared web app, and all your tenants access a single hostname. Your middleware, your mid-tier, could be an application layer with, say, shared message queues, and that is shared between all tenants. And then your data tier could be an isolated database. Could be specific tables or particularly blob containers. It could be any number of things. But fundamentally, there could be a mix. So we've talked about one end of the spectrum to the other in here in terms of tenant isolation, but actually you could sit somewhere in the middle, or you could sit on one end for some things and one end for other things as well. It really depends on what you're trying to achieve. Okay, so next is around automated single tenant deployment. So we talked about the importance of automation, and now we're going to talk about that in terms of single tenant deployments as well. So your application is fundamentally responsible for initiating and coordinating the deployment of each tenant's resources. So typically, solutions built in this model would make extensive use of infrastructure as code, as well as potentially the resource manager APIs. You might use that approach when you need to provision entirely separate infrastructures for each of your customers. Consider the deployment stamps pattern when planning deployments for this. Some of the benefits of this is that each data for each tenant is fully isolated, which then reduces the risk of accidental leakage. So that can be really important to some customers, as we've talked about, with high regulatory compliance overheads. But additionally as well, tenants are unlikely to affect each other's performance, and this is what we refer to as noisy neighbour problems. Updates and changes can be rolled out progressively across tenants, which will then reduce the likelihood of system-wide outages. But the risks to this model are that your cost efficiency is really low. Because you are sharing infrastructure between your tenants, if a single tenant requires spending a certain amount of infrastructure, then it's likely that 100 tenants will require 100 times that cost and expenditure. Additionally, things like ongoing maintenance, applying software updates, new configuration, is likely to be time consuming as well. So consider automating the operational processes and applying changes progressively through environments. You should also consider other cross-deployment operations like reporting and analytics across the whole estate. And likewise, ensure you plan for how you can query and manipulate data from an administrative perspective across multiple deployments. So let's move on to a fully multi-tenant deployment. So at the opposite extreme end to what we've just been looking at, you can consider a full multi-tenant deployment where all components are shared. You have one set of infrastructure to deploy, one set of infrastructure to maintain, and all tenants use it, as illustrated in the diagram on the right-hand side. Some of the benefits of this model are that it's attractive because of the lower operating costs with shared components. So even if you need to deploy higher tiers or SKUs of resources, generally speaking, it's still often the case that the overall deployment cost is lower than a single set of tenant resources. Additionally, if a user or a tenant needs to move their data to another logical tenant, you don't have to migrate data between two separate deployments. Looking at the risks of some of this deployment though, so you need to take care that you separate data for each tenant and do not leak data between tenants. You may need to manage things like sharding of your data, and additionally, you may need to be concerned about the effects that individual tenants can have on the overall system. So, for example, if a single large tenant tries to perform a heavy query or an operation, how will it affect other tenants? Also, determine how you're going to track and associate costs to tenants. So, if it's important to you, that's a really key thing to mention there, is that if cost is something that you want to control tightly and differentiate on a tenant level, in a fully multi-tenant deployment, that's obviously fairly hard to do. So make sure you have methods in place that can cater for that operation. Maintenance can also be simpler with a single deployment since you only have to update one set of resources. However, it is also riskier since any changes will potentially impact your entire customer base. Scale can be a factor to consider as well. You're more likely to reach Azure resource scale limits when you have a shared set of infrastructure. For example, if you use a storage account as part of your solution and then your scale increases, the number of requests to that storage account could reach the limit that the storage account can handle. So to avoid hitting resource quota limits, you might consider deploying multiple tenants of your resources. For example, multiple instances of your resources. For example, multiple AKS clusters or multiple storage accounts. Or you might even consider distributing your tenants across resources that you've deployed into multiple Azure subscriptions. There's likely to be a limit to how far you can scale a single deployment, and costs of doing so may likely increase in a non-linear way. For example, if you have a single shared database that when you run at a very high scale, you may exhaust its throughput and may have to pay increasingly more for increased throughput to keep up with your demand. So there are times where you may need to build another database instance in this example to still make use of performance, but also not pay additional amounts over and above what it is that you're looking to actually achieve. So you don't always have to sit at the extremes of the two scales that we've looked at there. So instead, you could also consider vertically partitioning tenants. Now you can do this using the following steps. So you can use a combination of single tenant and multi-tenant deployments. For example, you might have most of your customers' data and application tiers on multi-tenant infrastructure, but you might deploy single tenant infrastructures for customers who require high performance or data isolation. Deploy multiple instances of your solution geographically and have each tenant pinned to a specific deployment. That is particularly effective when you have tenants in different geographies. The benefits of this model are that since you are still sharing infrastructure, you can still gain some of the cost benefits of having shared multi-tenant deployments. You can deploy cheaper shared resources for certain customers, like those who you're trying your service with a trial. You can even bill customers a higher rate to be on single tenant deployments and recoup some of your costs. But looking at the risks from this deployment pattern, your code base will likely need to be designed to support both multi-tenant and single-tenant deployments. If you plan to allow migration between infrastructures, you're also going to need to consider how you migrate customers from a multi-tenant deployment to a single tenant deployment. You also need to have a clear understanding of which of your logical tenants are on which sets of physical infrastructure, so that you can communicate information about system issues or upgrades to the relevant customer. So from a back-end perspective, this is where internal processes and tools like configuration management databases or CMDBs play quite a huge part in the overall solution as well. So next is looking at horizontally partitioned deployment. So we've just looked at vertically partitioned. So this means that you have some shared components while maintaining other components with single tenant deployments. For example, you could build a single application tier and then deploy individual databases for each tenant. The benefits of this are that with a horizontally partitioned deployment, it can help you mitigate noisy neighbor problems. If you identify that most of the load of your system is due to specific components, then you can deploy separately for each tenant. For example, databases might absorb most of your system's load because the query load is high. If a single tenant sends a large number of requests to your solution, the performance of the database might be negatively affected, but other tenants' databases and shared application components, like your front end, may remain unaffected. However, the risks to this approach with horizontally partitioned deployments are that you still need to consider automated deployment and management of your components, especially the components that are used by single tenants. You still don't want to be deploying manually those solutions or those components in your solution when you need to deploy those individual parts. So think about those and think about how it can affect the overall part of the solution. So moving on to why you must practice DevOps. So first of all, how does DevOps help? So we've talked about a number of things that are reflected within the last part of this presentation, and the first thing here is deployment frequency. So we know that businesses benefit by making faster deployments possible. Deploying new processes and systems and applications more rapidly is something that we do use in DevOps strategies, and that makes your business operations more efficient. We've talked about the efficiency and business parts of the solution quite a lot earlier on in the talk. Improved customer experience is another thing as well. So when you develop your solutions faster, you are better able to serve customers. So some studies show that over 70% of businesses report improved customer experience since implementing DevOps. It is a real fundamental thing that you need to get right within your organization before you think about building a solution like this. It's not something you can easily retrofit in afterwards. Better office morale is another thing. So team morale experiences a boost from implementing DevOps. It improves collaboration, improves communication, and ownership. And those things are all really key. So when employees work together well, they're also happier, which improves morale. Okay, innovation, another thing as well. Everyone wants to work on the next greatest piece of edge technology. Everyone wants to work on the next biggest thing that is coming down the line, especially to get ahead of competitors. So more time for innovation is a key part of how DevOps can help you. Right, the result of streamlining your processes is improved efficiency. That leaves you a lot more time for brainstorming and developing new ideas. The more you innovate and improve, the more your business is going to grow and succeed because you are delivering those new features and your time to market is quicker than your competitors. And then finally, faster problem solving abilities. Right? DevOps allows businesses to solve problems quicker. So process problems cost businesses a lot of money. The longer it takes to fix a problem, the more money the business loses. So I just want to mention site reliability engineering, or SRE. So SRE is a software engineering approach to IT operations, and SRE teams use software as a tool to manage systems, solve problems, and also automate operational tasks. So SRE takes the tasks that have historically been done by operations teams, sometimes manually, and instead gives them to engineers or operations teams who use software and automation to solve problems and manage production systems. SRE is a real valuable practice when creating scalable and highly reliable software systems. It helps you manage large systems through code, which is more scalable and sustainable for system administrators managing hundreds or maybe thousands of machines. The concept of SRE comes from the Google engineering team and is credited to a guy called Ben Sloss. And SRE helps teams find a balance between releasing new features as well as making sure that they are reliable for users. Standardization and automation are the two fundamentally important components of the SRE model. So site reliability engineers should always be looking for ways to enhance and automate operational tasks. In that way, SRE helps to improve the reliability of the system today while also improving as it grows over time. SRE also helps support teams who are moving from a traditional approach to an IT operations to a cloud native approach. And that is something that we've obviously talked about extensively in here as well. And to not confuse the two together, we think about DevOps as being the overall approach to how we design, how we automate, how we increase business value, and increase the culture within our organization. On the flip side of that, SRE is not a completely separate practice at all. It should rather be considered an implementation of DevOps itself. And as we've talked about, it is not about pipelines, it is not about building and releasing software, but it is about the management, problem solving, and automation of operational tasks. So we've talked about and covered a lot of information in here. Obviously, feel free to watch this back again if you have any thing that you're not clear on. But the key thing here is that there are lots of options available depending on your requirements. Like most things in technology, especially in the cloud, there are lots of ways to do things. And the key thing with this is to make sure that you look at what you want to achieve really closely and how you're going to scale and how you're going to perform, so that when it comes to the future, you have not made decisions today which affect your ability to perform tomorrow. Because when you're building multi-tenanted applications, you may not have the ability in the future to change how you approach things to fix some of the wrongs that you've made today. So think about those things carefully and think about the considerations that we talked about at the beginning of the presentation and how the different architecture patterns and implementations of those patterns can help you achieve your goals in the future. And also think about how you use and adopt DevOps within your organization to be able to achieve what you want to achieve in a structured way, and how you use parts of DevOps like SRE to be able to help you scale effectively in the future and implement new features as well as automate your operational tasks. So with that, thanks very much everyone for watching. If you have any further questions, please feel free to find me on Twitter, and I will happily have a conversation with you about any of the points that you're not clear on, or if you want to run a specific scenario past me, then I'm more than happy to help with that as well. So once again, thank you to the organisers for arranging this amazing event, and thank you to you for all watching, and hope to speak to you soon.